All right, let's just jump right in. You know that feeling, right? You type a question into an AI chatbot, and boom, seconds later, a perfect answer just appears. It honestly feels like magic. But here's the thing. Behind that super simple, effortless response, there's this huge, invisible cost that, let's be honest, we almost never think about. Today, we're going to pull back that curtain and look at the real price of your prompt.
So let me ask you something directly. Have you ever actually stopped to think about the energy footprint of, say, that poem you asked it to write? Or that quick email you had it draft for you? Just how much power does it really take to get that answer back? Well, get ready for this, because the answer is pretty shocking. A single query to an AI chatbot, it uses about 10 times the electricity of a regular old Google search. Yeah, 10 times. All of a sudden, that quick question feels a whole lot heavier, doesn't it? Okay, so that's for one prompt. Now, here's where it gets really crazy. Let's talk about scale. Right now, as of this year, people are sending over 2.5 billion prompts to ChatGPT every single day. And remember, that's just one platform. The numbers they're absolutely staggering. And all of that enormous demand, it all points back to one place: data centers. I mean, think about it. Back in 2023, they were already eating up over 4% of all the electricity used in the entire United States. The trend line here is crystal clear. As AI gets woven into more and more parts of our lives, that global number, it's on track to at least double by 2030.
So what's the deal? Where is all of this energy actually going? To figure that out, we've got to look under the hood, so to speak, at the two main processes that make these AI models tick.
Basically, it all comes down to two big phases: training and something called inference. Training is, well, it's the really intense upfront learning part. You can think of it like the AI going to college, cramming for finals. And then inference, that's the day-to-day work. That's the AI actually answering your questions after it's graduated. Both of them are massive energy hogs, but for totally different reasons. Okay, so let's tackle training first. This is where a model just guzzles colossal amount of data. We're talking a huge slice of the internet, so it can learn everything about language, context, and spotting patterns. The philosophy in this phase is pretty much bigger is better. So these models have gotten so enormous that they need like whole armies of servers running 24/7 for weeks, sometimes even months, just to get through this one initial stage. And then you've got inference. Now, on its own, a single inference, just one answer to one of your prompts, uses way, way less energy than that massive training process. But, and this is a big but, its total energy cost is just jaw-dropping because of the sheer volume. Remember that 2.5 billion prompts a day number? Yeah, all of those requests add up to one massive, nonstop energy bill. Okay, so I've been throwing around words like immense and colossal, but those are still kind of abstract, right? Let's put some real, tangible numbers to this whole thing. Let's really try and wrap our heads around the true scale of this energy use. Okay, let's just take one model as an example: OpenAI's GPT-4. Just the training process, before it answered a single question, is estimated to have used up 50 gigawatt hours of energy. I mean, that's a number so big, it's almost meaningless on its own. So to put that into perspective, what does 50 gigawatt hours actually look like in the real world? Well, it's enough electricity to power the entire city of San Francisco for 3 full days. And all that energy was just to teach one AI model. That's before it even saw its first prompt from a user. And this brings us right back to that inference problem. There's the computer scientist Mosharraf Chowdhury who put it perfectly. He said it's basically a double whammy. The model is already massive, but we have a massive number of people using it. The models are huge, sure, but the real energy monster is the sheer scale of all of us using it every day. That's what turns inference into this huge continuous cost. So you might be thinking, okay, so researchers must be all over this, right? Calculating the exact impact. Well, they're trying, but there's this giant roadblock. Getting accurate data from the actual companies building these AIs is, well, it's incredibly difficult. We're essentially dealing with a black box. There's a researcher, Alex de Vries Gouw, who really studies the stuff, and he just nails the problem. He says, one very fundamental problem with digital applications is that the impact is never transparent. And that's the heart of it. Companies like Google, Microsoft, Meta, they tend to keep their exact energy numbers very, very private. And this secrecy has some pretty serious consequences. Without that data, we are completely flying blind. It's impossible to prepare our power grids for what's coming. It's impossible to really measure the true environmental cost. And it makes it so much harder for researchers to find more efficient solutions. You just can't solve a problem that you can't properly see.
Okay, I know this might sound a little bleak, but it is absolutely not a lost cause. There is a clear path forward. There's a way we can balance the amazing potential of AI with using energy responsibly. And it all starts with one thing: transparency.
So, how do we actually get there? Well, it's kind of like a chain reaction. And guess what? It starts with us, the users. When we push for transparency, that gives policymakers the political cover they need to actually encourage or even require disclosure. And once that data is out in the open, then we can finally hold these companies accountable for their environmental footprint. And that really brings us to the final, most important question of all. As this technology gets more and more woven into the very fabric of our daily lives, we all have to decide what the right balance is. What's the trade-off between progress and power consumption? It's a huge conversation, and it's one that every single one of us needs to be a part of.